stop. No, it's not going to stop. And there's never a point when you go, oh, I see the pattern. It's going to start over again. It never will happen. That's the nature of an ear. Ear meaning what? Not rational numbers. Irrational numbers stop or they repeat. This guy is irrational, so it doesn't stop and it doesn't repeat. It just keeps going on forever and ever and ever without ever repeating. It's a real shame that you guys are having college algebra in the fall instead of spring. Because if you were having college algebra in the spring, you could, along with all the mathematicians in the world, celebrate Pi Day. I'm not making it up. Every year, ladies and gentlemen, and you should Google this when you get an opportunity, every year on the third month, 14th day, at 1:59 p.m. Greenwich Mean Time, mathematicians all over the world will stand and in unison recite the first 100 digits of pi. It's a very tender moment, ladies and gentlemen. I'm not making this up. It happens every year. Every year there is a Pi Day celebration, typically in a European university, where mathematicians come from all over the world and present papers on pi, talk about pi, exchange recipes for pi, serve pi, I don't know. But they talk all things pi for that one particular day. Google it when you get get close to the Ides of March. Right before the Ides of March is the Pi Day. There's a guy there, I mentioned that you were Dr. Pi. There's a guy there who used to be known as Dr. Pi. I'm not sure he's still there. But he would, for the amusement of his audience, from memory, recite the first 10,000 digits of pi. To which we respond, get a life. That's right. Get a life, buddy. All right, come on. You got to memorize something slightly helpful. But he's called Dr. Pi. He did it. And it's on, if you can see it, if you care to watch the hour after hour, it's on video on the internet. So if you care to, if you're having trouble sleeping, put Dr. Pi on. It'll be a sleeping effort. All right. That's our most famous example of an irrational number. Who's got another? Or is there none? Yeah, E. Anybody familiar with E? This guy's going to show up when we get to logarithms. It's called Euler's number, E-U-L-E-R, Euler, mathematician, Euler's number. This is a number that shows up in anything that has to do with growth. If you got a petri dish full of bacteria and you want a formula for the way it grows, E's going to show up. If you have a human population and you want a formula, and there are formulas, sociologists have them, for growth in a particular population, E's going to show up. It is called, well, we'll get to the natural logarithm a little later on, but E is another example of an irrational number. You will have an E key on your scientific calculator, and you can see what E is, should you put E to the first power. Anybody got another one? Sorry? Yes, Ln. The natural law. Anybody got another irrational number? There's two so far. Got another one? What else do you put in your calculator that just keeps going forever? I'm sorry? Square root of 2 is a good one. Square root of 2, put that in your calculator, see what it equals. And you'll find out that there is an endless progression of decimal numbers that never stop and it never repeats. All right, listen to the emphasis of my voice, ladies and gentlemen. If the square root of 2 is an irrational number, what else do you think might be an irrational number?
Square root of 6.
Square root of 3. Mm-hmm. Square root of 3 is an irrational number. Square root of 5 is an irrational number. Square root of 6 is an irrational number. Square root of 7 is an irrational number. Hey, can we just go ahead and say that the square root of anything is going to be an irrational number?
No.
Why not? You got a problem? What's an exception? You got an exception?
Square root of 4.
Okay. Square root that doesn't come out to be a whole number. So you got a square root of 16. That happens to be 4. Is 4 a rational number? Is it a rational number? Now, you know it's rational.
Yes.
4 over 1. Or you could say it's a terminating decimal. Either way, this guy is completely rational. These guys that do not come out to be whole numbers are all irrational. So, true or false? Every square root of a... Let me see. I won't put this on the test, but just assume I'm talking about positive numbers. Every square root that doesn't come out to be a whole number is irrational. True or false? Every square root that does not turn out to be a whole number is irrational. True. So if it doesn't come out even on your calculator, square root of 27, that doesn't come out even. It doesn't come out to be a whole number. It's irrational. Square root of 37, square root of 48, they don't turn into a whole number when I enter them in my calculator. Therefore, they are going to be irrational. All right. Okay, again, listen to the emphasis of my voice. If the square root of 2 is irrational, what else do you think might be irrational? What? If the square root of 2 is irrational, what else might be irrational?
6.
Cube root of 2. Cube root of 3. Cube root of something that doesn't come out to be a whole number is also irrational. In fact, you're going to find in any root, the 27th root of 49, which does not turn out to be a whole number, any root that does not turn out to be a whole number is going to be irrational. All right, here's the big question, ladies and gentlemen. How many irrational numbers now do you think there are? Infinite. Yes, there's an infinite number of irrational. Let's take a look at some of the... You've seen this before, right? What do you call it? Number line, right? I hope you know, ladies and gentlemen, that number line is not its official formal name.
The real number.
That's its street name, all right? That's what it goes by. But its official name, what's on its birth certificate, is the real number line. Okay? Because there is a perfect correspondence between every single real number. You give me a real number, there's a dot on the line that corresponds to that real number. Likewise, you choose any dot on the line, there is a real number that corresponds to that. Okay, let's look at this real number. Question for you. How many rational numbers do you think there are between 0 and 1? How many rational numbers do you think there are between 0 and 1?
Is this including 0 and 1? Is this including 0 and 1?
Not including 0 and 1. Between 0 and 1. How many rational numbers?
Infinite.
Infinite. Let me go with infinite. That's absolutely right. So an infinite number of... Hey, I'll show you how you can get an infinite number of fractions. That's what rational numbers are, right? Fractions of infinite. Go a half. Take half of that. 4. Take half of that. And 8. You could go on all day, couldn't you, ladies and gentlemen? You could go on all day, literally, infinitely, just with those fractions. And that's just some of the fractions. So you bet there are an infinite number of rationals between 0 and 1. How about irrationals? How many irrationals are there between 0 and 1?